Good evening, Principal Sir, all the dignitaries, my dear colleagues, and the active learners. Myself, Shobhan Nandi, Assistant Professor of EC Department, BIT, and the Coordinator of Self-Driven Activity Group of IIC BIT. You know what scientists thought is that, can we make the machine learn like how human brain thought? Yes, you are right. We are discussing on the topic that is deep learning. It's my pleasure, great pleasure to conduct this webinar on hands-on deep learning by our eminent speaker, Mr. SABYASACHI Mukhopadhyay. Welcome, Mr. Mukhopadhyay, in our college. And I request Almaj to continue from here. Over to you, Almaj.
Yes, sir. A very good evening to respected Principal Sir, Professor Dr. N.C. Ghosh, our guest speaker, respected faculty members, and all my dear friends present in this meeting. As we know, the Ministry of Human Resource Development, MHRD, Government of India, is making every possible effort to drive innovation and entrepreneurship to emerge as one of the focal points of our education system. Taking part in this initiative, Institutions Innovation Council of Bengal Institute of Technology, in association with Indian Society for Technical Education, that is IST Students Chapter of BIT, present today's technical webinar on hands-on deep learning. Thereby, I, Almaz Akhtar from CSC First Year would like to take this opportunity to welcome you all to this wonderful technical interactive session, where I proudly announce that our today's speaker is Mr. Sabyasachi Mukhopadhyay. Sir is here today to share his insights and acknowledge us with deep learning, which is one of the most popular domains in the AI space today. Before starting this session, I kindly request all our participants to keep their microphones muted. If you got any queries, you can send it in the chat box or ask at the end during the question answer series. Also, just like the previous webinar, even today we'll be having few questions in the feedback form, and the first 10 performers will get the Star Performer Award. It will be completely based on first come, first service. Now I would like to request our Principal Sir, Professor Dr. N.C. Ghosh, to say a few words to commence today's session.
Thank you, Almaj. It's my pleasure that, I could manage time to reach on time. Just about 6-7 minutes before I entered into my home to attend this particular webinar. So I heartily welcome Dr. Professor Sabyasachi Mukhopadhyay, who is the Assistant Professor of BIMS and also Google developer in machine learning. So I, on behalf of BIT and on my own behalf, welcome you to this particular webinar. And also we have the team headed by Professor Arpita Chakraborty of IAC, means Indian Institute Innovation Council, and also Professor Shobhan Nandi, who is organizing this particular event, and we have Tripti Mukhopadhyay and all other IIC BIT team. So I heartily welcome all of you, and also our beloved students who are the recipient of this talk, who will be benefited by the talk to be given by Mr. Sabyasachi Mukhopadhyay. And I'm happy to note that it's a hands-on. So hands-on means, you will have to do something practically on deep learning. So of course, that will give you real understanding about the subject, because if someone gives a lecture, so sometimes what happens it is very difficult to keep everything in mind, to retain in the brain. So if it's hands-on, then definitely you'll have to retain the content, and also you'll have to work with the examples. So hands-on means it gives me a lot of pleasure that you are going to organize this event on hands-on. And students, I would like to mention that our IIC of BIT is trying their best to give you the best on the on different subjects, means, so that you can excel in your career as well as excel in your professional life. Means, it is the college who is providing all these facilities, so you'll have to take advantage of this. As you know, that time comes and time goes, but if you cannot be with the time, it is you are the loser of the everything. So students, try to take advantage of this type of webinar, and we have the experts who is also a Google developer. So definitely he has got the academic background as well as the professional background. So he understands what is to be taught and how it is to be taught and how it is to be percolated among the students. So without not going further, I will just again convey my sincere gratitude to IIC BIT team and also welcome our guest speaker. Thank you very much.
Thank you, sir, for your kind words. Now I would like to request the President of IICBIT, Professor Arpita Chakrabarti ma'am, to say something.
Thank you, Almaz. Very good evening. Welcome you all in today's session, Hands-on Deep Learning. So students, are you eager to learn? Are you excited to learn this most trendy topic, deep learning? You must be. Since a childhood only, we have started learning, at times under the supervision of our parents, and at times we ourselves through the process of penalty and reward. And it's no wonder even because we the human being having our own intelligence here. But the thing is, in this era of metaverse, digital twins, or internet of everything, the devices around us are also learning every day. They are becoming autonomous. They are behaving so intelligently, interacting with us. And most surprisingly, at times, our own creation are also assisting us. Like during the time of online shopping, we get to know this message, may I help you? It's very popular to us, right? So the machines are also learning every day. And not only that, they are recognizing things, they are predicting things. And this prediction is, of course, not fake like those Babas used to do with the parrots under the trees. These predictions are very much efficient and very much correct, of course. So predicting future is not a magic today. It's artificial intelligence there. And machine learning is a part of artificial intelligence, and deep learning is a subset of artificial intelligence, of course. So today we will be learning all these things from our eminent speaker, Mr. SABYASACHI Mukhopadhyay. So without delaying further, we should straightforward go to our main program. And welcome, once again, I'll take this opportunity to welcome you all and welcome Mr. SABYASACHI Mukhopadhyay to Bengal Institute of Technology. Thank you all.
Thank you, ma'am. Now I would like to request Professor Antara Mukherjee ma'am to introduce our guest speaker. Over to you, ma'am.
Thank you, Almaz. Myself, Antara Mukherjee, Assistant Professor of ECE Department, BIT, is going to introduce Mr. SABYASACHI Mukhopadhyay. Mr. Mukhopadhyay worked at CEMK in 2013. He was former scientist at Nanoscope. He was former Kolkata lead for Facebook Developer Cycle at Facebook app. And from August 2018 to December 2018, he was MLCC Felicitator at Google. He was former faculty of different management institutions and was former university faculty at West Bengal State Government and former faculty of business analytics and statistics at McCout. Mr. SABYASACHI Mukhopadhyay is a data scientist, faculty, works at RedX and TEDx speaker, champion innovator on the topic Cloud, AI and ML, Google developer, expert in machine learning. He was invited from different institutions for sharing his valuable technical talk and as a role of judge in different technical competitions as well as different hackathons. We are very glad to invite him and eagerly waiting to hear from him about the topic of hands-on deep learning. So welcome, Mr. Sabyasachi Mukhopadhyay. Over to you, sir.
Thank you very much to the organizing committee of BIT Kolkata for inviting me here. It's my pleasure, and it is the first time I am giving the speech on any platforms provided by BIT Kolkata. So thank you very much to all of you. Thanks to our respected principals, sir. Thanks to Orpita ma'am and Anna ma'am for the kind introduction as well. So let us start today's discussion that is basically based on the hands-on session on deep learning. So before we can start, just to give some guidance to the students, those who are planning to start their career in the data science domain. So basically you see that often this kind of questions comes up, that what are the things they should learn at first. So basically you see that whenever you are starting any domain, so the basics should be very strong, because you see it's not only about running the code successfully or getting some outcome, but you have to interpret them as well. Like you are planning to detect early stage cancer detection through AI-based algorithms or crop predictions through AI-based algorithm, whatever may be the solutions you want to provide, you have to interpret, you have to give the proper interpretation. So that's the reason you require to know the theoretical aspects as well. So linear algebra plays a very, very vital role, at least to get some idea about the basics on the matrix multiplication, eigenvalue, eigenvector calculations. Those are the very basic things, because you see there is one methodology in machine learning domain that is like principal component analysis. There you will require this kind of the concepts related to eigenvalue. So once you can understand them, then only you will be able to interpret the result whenever you are applying PCA on some data sets. So linear algebra plays one of the vital area. Along with that, definitely statistics and probability plays a very, very important role. So under the statistics and probability, you see descriptive statistics, inferential statistics. These two are the very, very vital area which you should cover up. And along with that, the probability in terms of the probability based theorem, which is completely based on the conditional probability, because you know there are a lot of applications in machine learning domain. If you find like naive-based algorithm, even those who are the Markov model, hidden Markov model, those are basically the dynamic Bayesian model. You will often require to deploy that type of the concept, because you see that whenever you have data in order of 10 to the power 5 or nearby 10 to the power 5, we generally go with the deep learning. But below that, machine learning does extremely well. That's the scenario we will talk about, because while making the discussions on the modern deep learning architecture, we'll see that how the machine learning evolved and an initial level why deep learning has not got the popularity, but how it get the fame in today's, which make them one of the most popular technology under the industry 4.0 era. So before going to that, another important aspect which I want to cover, because we have talked about linear algebra, the necessity of the probability and statistics. Along with that, often this kind of the questions comes up, that what kind of the job role we will get from the industry, and for that what kind of the languages we should know. Now you see that the students, those who are planning in the academic directions, MATLAB is fine, but if you are planning to launch your career in the industry, you have to understand that often we interact with cloud. So it is always better that if you have some knowledge about any of the cloud communicator languages, like we have the Python, Java, these are the cloud communicator languages. Now you see that especially in the machine learning or deep learning domain, all the frameworks are highly Pythonic. So it will be better if you know any of those Pythonic frameworks, like for example, it can be PyTorch, it can be ImageNet, it can be TensorFlow, Keras. If you know any of them, that would be quite helpful for all of you. Like today, we are going to explore one of the Pythonic frameworks related to ImageNet framework for implementing some of the deep learning architectures in our today's discussion. And definitely, for that, you should have a very strong grip on the Python as well. So anyway, I am going to guide you, nothing to worry about it. So this is one of the part, and definitely another thing apart from this particular language, in analytical angle, even for example, you can explore R as well, because you see R also a very good open source programming language that will also having extensive support in terms of doing the statistical operations. So apart from Python, R has also a very much popularity in this particular analytics domain. And for the visualization aspect, You can know any of the Power BI or Tableau. That also plays a very, very vital role, because if you know in Tableau, in Indian scenario nowadays, as per the market situation, you can get the 6-digit salary per month. So you can understand that these are the basic necessity why you should know about what are the industry requirements. So it can be the job roles related to ML architect, okay, data engineer. In case of the data engineer, you will have to handle the nowadays NoSQL servers, because you see the way that the overall background history, if you just make a overlook on it, just a brief look on it. So from 90s 40s era, as basically all the top level scientists from the developed country, they realized that the necessity of mimicking human activity. Can we have something which can exactly mimic the human activity? So from that, our journey with the neural network started, and gradually we started to explore in different directions while dealing with while making the theoretical evolution along with the nonlinear dynamics tools and signal processing. So already, if you see, there are several effective nonlinear dynamics method and Fourier transform. Those were highly explored in the domain of the computer vision in that era. But gradually, what happened that when from the 1960s, late of 1960s, actually people realized that we can use computer for storing data. So in all the developed countries, they started use of the computers in their offices, and late 1970s in India and other developing countries started to put emphasis on the computer-based approaches. So in those era, you know that basically the database having tabular structure. So we basically deals with the relational databases. But after that, you see during that era, all the software packages that were available completely at the commercial software packages, you have to buy them. So there is not much democratic approach in terms of the software. So those who had the fund, they can afford it. Otherwise, other institutes were suffering, and those who don't have the adequate fund. But during the late 90s era, when we started our object orientation journey along with Java, so in that time, Python was also in a very much baby stage. So thanks to one of the open source community Linux foundations and others also played a very, very vital role to nurturing the open source network. So that's the reason you see nowadays you are getting a lot of open source softwares, whether it is Python, whether it is R, or whether it is Weka. So everybody is having the democratic right to explore all those open source softwares. You can contribute on them, you can freely avail them, you don't have to buy those softwares, and you can do the extensive data analysis application over it. So this is one of the angle, because you see, apart from the mathematical development, you require some softwares to process them. So those facilities we started to get. But if in those era, we have seen that in 80s and 90s era, we have seen the huge popularity of the techniques like support vector machine. That's the reason in that era, Bhapnik got the huge popularity, who is one of the prime contributor in the development of the support vector machine. Then we have seen the rise of the random forest and all those technologies. But you see what happens that in machine learning, they are not performance-wise scalable, because the activation function is being used. If you see the curve of the activation function, whether it is sigmoid or the tan hyperbolic, the curve is not performance scalable. What happens that whenever you are continuously training data in machine learning, you started to get some better accuracy, but after a certain level, the performance saturates. It can be nearby accuracy, for example, it can be nearby 85%, 90%, but you are not being able to achieve 100 or nearby 100%. So that is one of the problem with the machine learning scenarios. So philosophically, what happens that if you see what are the activation functions relating to our human activity, like even as being human, you can work for 10 hours, 12 hours, 14 hours, 16 hours a day. Then what will happen? Your performance will be saturated. So it is not performance-wise scalable. So that performance-wise scalability thing has been introduced by deep learning, but not at the initial level. When the deep learning theory was developed in 1980s, mathematical theory, then Ian LeCun, one of the godfather of deep learning, he actually came up with LeNet. We will very soon discuss about that architecture of the LeNet. The main problem was LeNet in 1980 when it was introduced. The major drawback, one of the major drawback was that in those era, they have used the activation function as sigmoid, one of the problematic scenario. And you see that we all know that the deep learning, to get success, high level success, we require data in order of 10 to the power 5. Otherwise, the overfitting scenario may take place. So in those era, you don't have the huge capacity of data storage. That is another problem. And data processing is also important, because we talked about mathematical development, we talked about open source activities, which implies the software development. But we don't have the enough support to process the data processor you require. So in that, hardware development is also very, very important. So in before 2012, NVIDIA came up with GPU, and 2016, Google came up with TPU. We don't have that type of the processor support. So that is another problem which Linux suffered in 1988. So during that period of time, there's a reason machine learning performance, overshadowed the deep learning architectures like Linux. Even support vector machine and other machine learning algorithms have done extremely well in those areas. Even in early 2000, they have a huge popularity. But you see, like as I was discussing about the structured data sets, like the which can be dealt with the RDBMS and all those things. Now you see that as the era started, with people started to explore with the internets very often. So we were continuously generating the semi-structured data. So for example, if you are doing LinkedIn, you are doing some professional post there. So if you are writing some text, you are posting some images, videos. So these all are the unstructured part. So your login activity, your logout activity, and your overall duration time is stored in the columnar format. So that information is stored in the structured format. But your post, whether it is you are sharing images, videos, you are writing some text, that is the unstructured part. So in a holistic manner, you are generating the semi-structured data. In a similar fashion, if you see, in case of Facebook or while using emails, we are all generating the semi-structured data. And nowadays, if you see, the number of the stars in the universe is equal to the number of the bits in the digital world. So humongous data generation is happening, and the digital world is expanding in exponential order. So you can understand that nowadays the data in order of 10 to the power 5, if you see, it is quite possible. And that's the reason you see that the need of hour was the deep learning. So Fei-Fei Li from Google, he highlighted that we require some sort of the database where we can store huge amount of the data. So what he does, he basically prepare a large amount of the data set restorations with 1,000 images with 1,000 features. So you already have the data in order of more than 10 to the power 5. You can store them, and see launched the competition named ImageNet competition in 2010. So ImageNet was launched in 2010, and during 2012, we got this. We got one of the great frameworks when the competition was launched from the 2012. So whatever the deep learning architecture nowadays we discuss, AlexNet, VGGNet, InceptionNet, ResNet, or ExceptionNet. So all these are either the winner of those ImageNet competitions, or they are the first runner-up. So that support actually in 2012, when AlexNet came up, they got that kind of the support of those processor powers, because first of all, they have the huge capacity of data storage thanks to Fei-Fei Li's initiatives. And second one is that they got the activation functions like ReLU in those era, because you see, if you require something performance-wise scalable, where the philosophy of the superhuman activity comes up. Because you see, whenever we are talking about the superhuman activity, we know that there is no concept of tiredness or no concept of performance saturations. So you require something, you require a graph which should look like a ramp-like function. So that type of the scenario has been taken place with the arrival of the ReLU-like concept as an activation function. Although ReLU has some problems related to the vanishing gradient problem at x equals to 0, that's the reason we have seen the leaky ReLU, parametric ReLU to overcome that type of the shortcomings. So that is the era. One of the support they got, the database, they have the huge database. Second one is the ReLU as an activation function, and third one with the support of the NVIDIA from 2012 onwards. And that is the reason deep learning got the required acceleration which they need. And that was the need of hour, because nowadays, as I told you, that the databases, if you see, are increasing exponential order. Okay. And even in this way, that goes on, by 2035, according to Moore's law, all our physical processors performances will be saturated. We require something related to the quantum domain. That's the reason you see nowadays we often are talking about quantum machine learning, quantum deep learning, quantum cryptography, quantum blockchain, quantum IoT. So within now, it is 2022. By next 13 years, we very soon have to move to quantum domain to sustain ourselves. But as of now, still we have a span of one decade and a little bit more than that, where we can deal with all those classical platforms very easily and quite elegantly. So anyway, without further delay, let us start the hands-on session. So that was the background aspect which I want to share with all of you, because suddenly starting hands-on is not a good thing. Before that, we have to give some of the background aspects. So that we have covered so far. So now let us make our required discussions. So let me share the screen with all of you. I think the screen is visible now. Okay, so you see that this particular notebook which I am sharing, this is the original notebook. Okay, what I will do, I will reproduce the result in a demo notebook, and I would request all of the participants to please open Google Colab. Okay, so we will implement all those things in Google Colab. So you can go there, like here I have typed Google Colab. Just go to the Google search, write Google Colab. Okay, so once you type Google Colab, you will see this particular link will come up. Welcome to Colab Laboratory. Just click on that. So once you come that, you see this particular link is given there. New notebook. Okay, you can open it. So the new notebook will open up. Okay. So once this new notebook opens up, so you will see this kind of the following scenario you will be able to observe. That some untitled something name has been given there with IPY interactive Python notebook extension has been given there. So you can put some, you can give some name there. For example, here in our practice purpose, we can put AlexNet demo. Okay, AlexNet_demo. I am giving such type of name. You can put similar kind of name just to practice it, because don't worry, I will share original notebook with all of you. So all of you will get a lot of exposure in terms of the practicing. So nothing to worry about it. You can see in original notebook, some theoretical details are given there. Theoretical background has given there. Already I have mentioned few of those points during our discussions. So all the theoretical necessary things are attached with this notebook. So in notebook, not only the coding portion, you will get the theoretical support as well. So nothing to worry about it. Okay. So I will email the notebook to the organizers. So they will basically share with all the participants. So you see that we will start our discussions. Already during the discussions, we have already covered all the necessary parts. Now we will make our discussion related to the architecture. But before going to that, I just want to give you some important aspects. Those who are new to Google Colab, those who know, that is fine. So you see plus code and plus text, these two pop-ups are there. So for example, if you want to add some theory, you can click on plus text and you can write the theoretical portion the way I have added the theory portion. If you want to write some code, so you can click on this plus code button, and you see there is an opportunity where you can write the code here. So there you see there is a run cell button is there. You can click on that and you will be able to execute the entire code. Okay, so that is the entire procedure. So during our execution of code, you will be able again able to see that particular scenario. So nothing to worry about it. So let us check out that we talked about the NVIDIA requirement of NVIDIA. We talked about the requirement of the scalable activation functions like ReLU. And all those things we have talked about, that how the AlexNet is getting advantage over the LeNet. So let us take a look at the overall architecture of the LeNet and AlexNet. So in the left hand side, this one is the LeNet architecture, where you can see image 28 by 20 image has been taken there. You can see 5 by 5 convolutional layer. Okay, so there are two 5 by 5 convolutional layer followed by 2x2 average pooling layer is there, and after that you can see there are 3 fully connected layers. Okay, this was the LeNet architecture. Whereas in case of the in case of the AlexNet, it was participating in the ImageNet competition, and it has a huge database. So you can see that the image it is a color image with 224 by 224 with RGB 3 channels, red, green, blue. And you see there are how many convolutional layers are there. You can see there are 5 convolutional layers. Okay, and here instead of using the average pooling layer, we are using the max pooling layer. And along with that, you can see there are 3 fully connected layers are there. So fully connected layer portions are quite similar with the LeNet, but during the execution, you will see that apart from these architectural differences, we also having the differences like activation function. Use of the activation function will also play a very, very important role. And apart from using the weight decay in case of the LeNet, which has been used to reduce the overfitting scenario, here we will use the dropout layer. So those kind of changes are there apart from the LeNet architecture to AlexNet, but it was not being developed it was not a matter of a single day. You see, LeNet was developed in 1988, and AlexNet was developed in 2012. So 24 years, there is a gap of 24 years. So you can understand that it took scientists 24 years to come up with this optimized deep learning version. Nowadays, we are getting the facility, we are getting the blessings of it. Okay, so let us start our explorations. So first of all, as you know, those who are familiar with Python and Pythonic platforms, that whenever we start, we have to install some sort of the frameworks and corresponding modules to run the code. So first of all, what we'll do, we will install MXNet. Okay, then what we'll do, you will install D2L to provide the deep learning, person independent deep learning supports, and then from MXNet we will import NP. Okay, NumPy and NumPy NPX, NumPy extensions. Then in mxnet.gluon we will import NN neural network, and from D2L we will import the MXNet as D2L to give you all the version independent support. Then we'll do the basic setup, NPX NumPy extension setup. After doing that, what we will do, we will initialize net equals to NN.sequential. Then we will use a larger 11 by 11 window to capture the object. So at the same time, we'll use the stride of 4, which can greatly reduce the overall height and width of the output. Okay, so here the number of the output channel is much larger than in case of the LNet, sorry. So what we are doing, as per the architecture we have seen, same thing we are basically defining here in the code. Okay, the architecture, if we go back there, if you see this particular AlexNet architecture, so we are starting with the kernel size 11 cross 11 in case of the convolutional layer, and with the stride 4, the same thing we are doing here in the code. Okay, same thing we are implementing here, so nothing to worry about it. I will post the code in your comment box section. Okay, so all of you will be able to execute it. So now just have a look at it. So you see that we are starting with a convolutional 2D, okay, con 2D layer, n.con 2D, kernel size 11, okay, your stride is 4 and activation layer is Lelu. Okay, after that, what we are doing, we are putting the max pool layer, okay, nn.maxpool 2D with the pool layer size. You know that 3 cross 3 by 3 kernel size we are using, and stride with 2. So accordingly, we have given those information. Followed by that, what will happen? We will now making the convolutional window a little bit smaller. So setting the padding to 2 for the consistent height and width across all those inputs, and increasing the number of the output channel. So now you see from 96, now in next layer, the output number of the channel is 256, n.con 2D, 256 kernel size 5, padding 2D, activation function we are using is ReLU, and nn.maxpool 2D, where we are using the pool size 3 with stride 2. Okay, then what we are doing, we are putting some successive 3 convolutional layers in a smaller convolutional window. So if you see as per the architecture which we have observed, the same thing we are doing here. So here what we are doing, we are keeping the kernel size 3, padding 1, activation functions ReLU. Like I was mentioning, that we will use the activation function ReLU. That is the major, that is creating the major difference between LNet and the AlexNet architecture. Okay, and finally, after using the max pooling layer with pool size 3 by 3 and stride 2, what we are doing, we are making them attached to the fully connected layers. So here you see all the dense layer, fully connected nn.dense. You see 496 will be your channel output, activation ReLU, with putting some dropout layer. That here the value of the dropout is 50%. So 50% will be dropped out in order to reduce the complexity from the network and to have in order to avoid the overall dropout scenario. Okay, and finally output you will get the 10 classes. So nn.dense 10. That's the reason, because you see, instead of using the 1000 classes, here we will use 10 classes, because it will give you the output very faster. Because original AlexNet paper, it was 1000 classes when they have solved the overall architectural view. So if you see, just have a overlook on it, whatever we have implemented in the code, that was given in the architecture layer. So exactly the thing, whatever given in the architecture, we have incorporated in the code. So you see what I will do at first, I will implement it in my AlexNet demo notebook. So what I am doing, I am pasting it here, you see. And what I will do, here you look that there is a run cell button is there. So I am clicking on run cell button. So the code is executing there. And similar way, you will be able to execute it. I will post it in the comment box section. Okay. So all the necessary notebooks, whatever, necessary modules and everything will be downloaded. Okay. And then what will happen? We will be able to execute the further operations. So let me send you in the comment box section as well. Just a second. Okay, so there is a limitations in the number of the characters there. So that's the reason you will not be able to see entire portion of the code at a glance. So I have to take a multiple attempt to send the whole portion of the code. Okay, so let me see that how much portion I have been able to deliver in the comment box section. Just a second. Okay, so max pooling layer 3D. Okay, reduce the height. Now I am sending the next portion of the code. Okay, so in a bifurcated way, actually I have to send the entire portion of the code because of the limitations in the character in the comment box section. So now I believe all of you will be able to see the entire portion of the code. Okay, so let me go back to sharing the screen. Okay, so now you see, just look at the screen and align your code properly, because you see in Python, if you can't align any Python or Pythonic platform, if you can't align the codes and line up the code properly, or if you don't put the proper spacing, you will be able to see the execution indentation error. Basically, in other programming, most of the programming languages, we can put some spaces as per our requirement, because this gives you the coding elegancy. Okay, which your code looks much more beautiful and other things. But in case of the Pythonic platforms, Python or Python platforms, you have to put the proper spacing as per the requirement. Unnecessary spacing will lead you to indentation error. So that's the reason, make sure that you are giving this proper spacing as you can visualize in the screen, entire screen. Okay, so let me know once you are done in this execution of this portion. Here also you can see my demo code has run successfully. So once your code runs successfully, you see the green tick will be there. Okay, because your code is running, execution of the code portion is done. So here you see all the necessary frameworks and modules have been installed there successfully, and we have been able to generate the entire architectural structure which we have defined in case of the AlexNet architecture. Okay, so now let us proceed to the next portion. Some comment has arrived, let me check. Okay, already somebody has said it. Thank you. So now once this portion has been done, okay, so let us move to the next portion. What we will do in the next portion. So in the next portion, we will construct a single channel data. Okay, that example with both height and width having 224 to observe the output shape of each layer. Okay, it can match with the AlexNet architecture. Okay, so let us try to execute that portion. So what we'll do, I will share this portion of the code with all of you in your comment box section, so such that you will be able to run this portion will be quite easily. I am unable to copy the code. Just a second. So for those who are unable to copy the code, what I am doing, just a second, give me a minute. Just let me show you that how to execute this portion of the code. Then I am giving you the solution. I thought that I will tell at the end, but now let me tell it, because there may be the cases that from the comment box you will not be able to, maybe you are not able to copy the code. So this portion here, I have executed the code successfully. So you can see, just let me explain this portion, then I'm going back to you. So you can see that different layers according to their shape has been demonstrated here. So you see, like the way I have defined print layer.name. So every layer name, convolution layer or pooling layer or dense layer or the dropout layer. So every details are given there. Output shape along with the, you see the /t space is given there. So output shape. After that, you see some with the tab sign, you have given some space and x dot shape. So corresponding shapes has been given there. The number of the layers, number of the what will be the channel number of the channels, and what will be the kernel size. So according to every details has been given there. So in this way, you can print the way you are defining the entire architecture. Now for the students, those who are unable to run it, so let me just share my GitHub account details. Okay, so if you go to this GitHub repository, which I have defined, which I have designed for the students to guide the students, you will be able to see that VGG Net and AlexNet. Okay, these two things are there. Okay, I will give you the demonstration for these two modern architecture, so you'll be able to execute it here. Okay, just go to my GitHub repository. For the students, I am gradually updating all the necessary contents in the GitHub. You will find blockchain related stuffs. You will find other machine learning and deep learning related stuffs. So you can follow me in the GitHub. Okay, make sure that all of you have the GitHub account. Okay, so you can easily download and get the update, all the new things which I will upload if you follow me there, and you can download all the necessary codes there. So whatever the script I am running here, it is available in the GitHub. You go there, you will find that AlexNet and VGG Net. There are two GitHub repositories are there. So you can, as of now, you can download the GitHub portion. Okay, you see. Okay, just a second. As of now, I'm just giving you the link for the, go search AlexNet. Okay, there is the link of the AlexNet will be there. Just a second. Those who are finding difficulties for them, I am also sharing the link of the AlexNet repository. Just a second. So you can easily download it from here. You see, I have shared the AlexNet repo link as well. So you can easily download it from there. Okay, and also I will definitely email it to our respected organizers, so they can also give you all those notebooks as well. So as of now, use this particular repo link. Okay, where you will get you will be able to execute those who are finding difficulty in terms of reproducing the results. So let us go back to the original notebook. So anyway, so we are discussing on producing construction of the single channel data example with both height and width of the 224 and getting the output shape of each layer. So already we have incorporated those things. Now in the next portion, what we'll do, we'll do the reading of the entire data set. So now you know that although AlexNet is trained on the ImageNet paper, which we have seen in case of the Fashion MNIST, all we know that it took original code execution took several days of time because they have to predict the 1,000 classes. Okay, but here we are predicting the 10 classes. Okay, so that's the reason what we will do. We because we want to see the output as of now. Okay, so that's the reason. What we will do, we will first start with the 28 by 20 resolution, but we have to make the themes work for the input image size of 224 by 224. So we have to upsample them, although this is not a great way to do it, but in our case, it is 28 by 28 image because we want to get the output of the 10 classes. So here we will do the upscaling, okay, upsampling basically. So what we'll do, we will upsample it to 224 by 224 and in order by performing the resize operation. So how we are doing it, you see, we are considering the batch size 128. Okay, so batch size equals to 128. So train iter or test iter here, we are taking D12 the data load function under MNIST, where we have defined the batch size and we are using the resize argument of the parameter to upsample it from 28 to 224 data size. Okay, so let us do it here. So let me showing you with the same steps in case of the AlexNet demo window. Okay, so you can see it will run, it will do the proper execution. You see all that necessary data download has been executed. And for the students and other participants, I am sharing the same thing in case of your comment box as well. Those who are able to, you have the lot of options, like you can directly download the notebook from my GitHub repository and you can reproduce those results, or you can simply follow the comments, the comment box section where I'm sharing the coding portion. Okay, so you can follow any of those steps. So now let me share the screen. Okay, just a second. So this, after you have been able to successfully implement this particular portion, now what we'll do, we will simply go back to the original notebook. Okay, what we will do now we can start training of the entire AlexNet. Okay, compared with the LeNet, we will see the main change here is that the we are using another main change is the smaller learning rate. So much slower training due to deeper and wider network will happen, and the higher you can see the higher image resolution, and which will be the costly convolutional process. So this particular execution of the code will take several hours of time. Okay, once you will be able to execute this code, you will get the following kind of the figure, where you can see that epoch has been given in the x-axis and y-axis is giving you the idea of the percentage of the accuracy. So the more the number of the epoch will progress, you see the overall loss, training loss will be reduced. Okay, and you can see the test accuracy and the training accuracy, what we are observing here. You can see after executing it, we can get the training accuracy 87.9% and the test accuracy is even more than that, 88.6%. So there is no overfitting at all, because when the overfitting scenario happens, that when your algorithm does very well in case of the training data set but miserably fails while doing the validation steps. But here you see it has done very pretty well in case of training data set, as well as during the testing accuracy, you are getting better result than even the training accuracy. For the unknown sample, it is doing much better. So you see, accordingly, what we have done here, we have defined the landing rate as 0.01 along with the number of the epochs 10. So for the, as the number of the epochs will progress, overall the validation error will decrease. And you see, accordingly, we have executed this portion of the code. So let me send it in your comment box section, as well as also show you that how to run it. So again, you see, once we are going to run that code, you will see plus code plus text button will be there. So as I mentioned earlier, that plus text button will be to add the theory portion, and plus code button will be to add up the code portion. Okay, so you can just put it there and you can click on the run cell button. So you'll be able to see that gradually the graph will be generated. Okay, it will take several hours of time to give you the entire shape. So once this process will be completed, you will be able to see the following graph, okay, which you can observe here. So in a nutshell, if you see the overall AlexNet structure, what we have observed, that AlexNet has a very similar structure of the LeNet, what we have seen there, but here we are using the more number of the convolutional layer, okay, and a larger parameter space to fit the entire large scale ImageNet dataset. And today AlexNet has been surpassed much more effective architectures. Okay, but it has a very, you can see that from shallow to deep network, it has been used nowadays. Nowadays, we have the, for example, VGG Net, which has better performances, where the block concept started, which you will see there. We have the ResNet, we have the Inception Net, we have the Exception Net, but AlexNet does the first job, which showed us the ray of hope that deep learning can be an evolutionary technology to apply in a large scale purpose. Okay, earlier it was only limited to mathematical architecture because LeNet failed to create impact on a large scale. So only the mathematical theory was available to us. But this AlexNet was the first important important contribution in this particular domain, okay, which gave us the ray of hope. So you can see that although it seems that there are very few more lines in case of the AlexNet implementation than in LeNet, like I mentioned, that it took academic community several years, 24 years actually, to be exact figure, 24 years to come up with the successful implementation. And thanks to the NVIDIA they came up with GPU, thanks to Pepe Lee for our initiative to store the last data set by launching the ImageNet competitions. And obviously the research group, they developed the AlexNet architecture. And you see Dropout, ReLU, and other people saying where the key played a very, very key role in case of the achieving that gate accuracy. Because in case of LeNet, they used wet dig instead of Dropout, but AlexNet, we have seen the use of the dropout layer along with the activation functions like ReL. So that was the part of the AlexNet portion. So let me share this last portion of the code in your comment box as well. So as per your utility, you can use it. Either you can directly copy from your comment box, or you can use the use my shared link of the GitHub. So let us proceed to the next portion, very, very important portion that is related to the VGG Net. Okay, we will see how the blocks concept has emerged. Okay, because today's session is quite a small session, so I will try to give you some idea that how this progression of the modern deep learning architecture has been able to proceed it, and all of you will get some confidence to implement those, reproducing those results. If I get in near future much more conducting much more sessions, then definitely we can go to much more different insights. We can take a look on the different insights of the other architectures as well. So in the case of the VGG Net, okay, so before I start the execution of the VGG Net, let me share the link of the GitHub link, okay, of this particular notebook where you can access this particular notebook. Just a second. Okay, so if you see there, you can, if you are following my GitHub profile, you can directly download it from there, or you can, I am also sharing exact repository, okay, where you will get this particular VGG Net notebook. Those who already found, that's fine. Those who are in difficulty, for them, I am sharing it in your comment box. So you can see this is the link of the VGG Net notebook, okay. You can access it from there. So let me go back to our discussions, okay, by sharing the, just a second. Okay, so as we have seen, that the AlexNet has given us the ray of hope to implement whether we can proceed with the deep learning in a large extent. Now you see the VGG Net. What is the beauty of the VGG Net? Because you see AlexNet, although it got the humongous success, but it was not unable to provide us the general template to guide the subsequent researchers in designing their desired new networks. So that kind of the guidances we got from the VGG Net. So thanks to the visual geometry group of Oxford University, they came up with this interesting guidances while providing us the general template of developing a new network architecture. So that's the reason it is VGG. So VGG name comes from the group name Visual Geometry Group. The abbreviated format is VGG. Okay, it was developed by Oxford University. So as you see, like the earlier notebook, here also some relevant theoretical portion has been given there. So you can easily read those theoretical portion. Apart from, you are getting the coding support. Okay, so this particular work, if you see, this is a basic building block of the classic CNN. Okay, CNN architecture, which we have seen. So first of all, you will have a basic block structure under this very general template for designing any deep learning network, where we will have a very general block structure. Like, first of all, a convolutional layer with padding to maintain the interval resolution. Second one, a non-linearity such as ReLU, activation function ReLU will be there. Okay. Then third one, what is the general architecture? That pooling layer, such as a max pooling layer. Okay, will be there. So one VGG block, each of the VGG block, remember this block-like architecture, concept of the architecture within architecture started, which gave us the general template of defining any new kind of the modern architecture. Okay, that comes from the VGG Net. So that is a huge contribution from the VGG Net. So a particular VGG block will consist of a sequence of convolutional layer, followed by a max pooling layer for the spatial downsampling. All of us know that how this kind of the max pooling layer does the downsampling job. And along with that, what in case of we will have the use of the nonlinearity, like activation functions like ReLU will be obviously there. So in the original paper, if you see the VGG paper, which has been developed by the Gisserman, okay, Simonian and Gisserman in 2014, actually it came up 2012 AlexNet and 2014 VGG Net. Okay, the authors employed a convolution with 3cos3 kernels with padding 1, okay, and 2cos2 max pooling layer with stride of 2. Okay, so let us see the development of the VGG block function. That means what will be the difference with the earlier code which we have implemented in case of the AlexNet, that here we have to define a particular block function to execute the block operation. Okay, so VGG underscore block function we will define here. So just a second, let me show you, give you the idea of the coding portion. So if you see that this particular function, this VGG underscore block function, then it will take some parameters as well. Or whenever all of you know from the basic knowledge of your programming that whenever we define some function, we have to define the parameters within it, right? So what are the parameters we are going to take here? What are the arguments we are going to take here? Number of the convolution and the number of the channels. These two arguments we are going to take here. So same steps we will follow. PEEP installation of the MXNet architecture installation, D2L architecture installation we will do. All those framework installation we will do. Then what we'll do from MXNet, the same step, importing NumPy and NumPy extension npx. Then from mxnet.gluon we'll do the importation of the num-nn, okay? And then from D2L, what we'll do, import MXNet as D2L, like the same steps we have done. After the installation of the frameworks, we have done the required modules, installation, downloading of the required module, then same thing, npx.setup. After that, you may remember during the AlexNet, as per the architecture basis, we have defined the number of the convolutional layers. Okay, what are the layers according, what will be the kernel size, what will be the stride size. So in this way, convolutional and max pooling layer, dense layer we have defined. But here, instead of doing that, we are basically developing a general template. So we are defining a particular function named VGG underscore block, where we are taking two particular parameters as the input, number of the convolution, number of the channels. So and VGG underscore block is the function name, where we have the two important arguments, num underscore convolutions, which is defining the number of the convolution layer, and num underscore channel, which is defining the number of the channels. And then block equals to nn sequential will be there. Then you are running it in a for loop. So as per your requirement, you can change the number of the layers in different blocks. Okay, so you see in a range number of the convolution layer block dot add, you will keep on adding the blocks, required blocks. So we know that under the block there will be convolutional layer as well as there will be max pooling layer. So accordingly we're just defining them. Okay, so number of the channels, kernel size 3, padding 1, activation function ReLU, then block dot add again, nn dot max pool 2d, pool size 2, and stride 2, like that they implemented in case of their paper. Gisserman has implemented in their paper of the VGG Net paper, that there will be the kernel size will be 3 for your convolutional layer and 2 for your max pooling layer. The same thing we are doing. Padding was 1 there and stride for the max pooling layer was 2 there. So same thing we are doing here. If you see this particular theoretical section, if you visit there, you see in their paper, like I mentioned there, you see in the original paper, BGG paper, Simonian and Gisserman in 2014, the authors employed convolutions with 3 cos 3 kernel with padding 1. We have done the same thing in the coding portion and 2 cos 2 max pooling with stride 2. So same thing we are doing in the coding portion. You see, whatever the theoretical section has been defining, we are exactly implementing in the coding portion. So we are not doing anything, any other thing. We are just following the steps has been implemented in the theoretical in the paper. We are just incorporating those portion in the coding mode. That's it. So then what will happen after defining the function? All of us, we know, we will return BLK. Okay. So in this way, defining downloading of the necessary frameworks, modules and function definition is done. So what I'm doing, I am reproducing this particular result in the new notebook. So while doing it, remember that put some new name. Okay, so execution of the code is going on there, earlier code. So just define new notebook. Okay, now under the new notebook, put some name like VGG demo. Earlier case you have given there like AlexNet demo. So put some name like VGG demo. Okay, give the name like VGG demo. Okay, so under that, what you do, you just put the code portion here, okay, and click on the run cell button. So your code will keep on executing. I am sharing the same code in your comment box as well. Those who are able to download the notebook, fine, you can do it from there. Also, you can reproduce it from your comment box as well. So in the comment box, you can see I have sent you the code. I have copy pasted the code there, so you can easily access it from there as well. So let us go back to the VGG demo notebook. So you see the code is executing 1 by 1 steps. So let us go to the original notebook to execute the next portion. So now we have seen that how the entire MXNet, you see downloading all the necessary frameworks with MXNet D2L and all that other things has been incorporated very, very elegantly. Now what we will see, we'll make a look on the VGG network, overall VGG network. Like the AlexNet or LeNet, we have seen the VGG network can be partitioned into 2 portions. Okay, first consisting of the mostly on the convolutional layer, pooling layer, and the second one will having the fully connected layer like we know. So the convolutional layer is a part of the network which connects several VGG blocks, okay, which can be defined in the VGG underscore block function in succession. So the following variable convark, which is providing with the convolutional architecture, okay, as a list of tuples will be there on part block. So what will happen there, within a general block template, there will be convolutional layer followed by the max pooling layer in a simple one. Then finally, what will happen? A fully connected part will be similar, like the way we have implemented with the AlexNet. And AlexNet also followed the same fully connected part Jan LeCun used in his initial network, LeNet. Okay, so those parts remain same. So the original VGG network, which has been implemented in the paper, they had the 5 convolutional blocks, along with first 2 have 1 convolutional layer in each case, and the latter 3 containing of the 2 convolutional layer in each of them. And the first block having the 64 channel output. Each subsequent blocks double the number of the channel output, and finally reaches the number reached at 512. Since the network uses 8 convolutional layer and 3 fully connected layer, they have given the name like VGG11. Why VGG11? Because 5 convolutional layer, 3 fully connected layer. In our earlier example of the AlexNet, we have used 5 convolutional layer and 3 fully connected layer. That's the reason it was AlexNet 8. Here we are using VGG11. Why? 8 convolutional layer and 3 fully connected layers. So 8 plus 3. It's as simple as that. VGG11 will be there. So same thing we will implement in our coding portion as well. So you see, this was the AlexNet architecture. All of you are familiar with that. Earlier we have seen. This is the general VGGNet block architecture. Under the VGGNet, you see, as per the definition in the paper, 3 cos 3 convolutional layer, as per the kernel size, padding 1. So block comprises of convolutional layer as well as the max pooling layer. You see, max pooling 2 cos 2 max pool, which try to as per the defined in the paper. And same thing we have defined in the code as well. So this is the general architecture. So you see, the block framework is giving you the general architecture of defining to come up with a new template for defining any new, come up with a template for defining any new network architecture under the deep learning. And you see this convolution, this fully connected layer remains same, like the AlexNet we have seen, in case of the LeNet we have seen. So this portion remains same. Now, what we are doing, we are basically defining the convolutional architecture. As far we have seen that you see the channel size will becoming double as the situation progresses. So 64, 128, 256, 512, 512. So you see what we'll do, we will implement this particular portion in our VGG Net demo. Okay, you see all the necessary downloading has been done. Now we will incorporate the next portion of defining the convolution architecture. So conv architecture. So just I am putting it here and clicking on the run cell button. So this portion of the code will run. Also, let me send the same thing in your comment box as well. Okay. So you may follow it from the comment box as well. So now let me go back to the notebook, original notebook. Okay. So here you can see we have implemented this particular portion. Now following code, what you will do, you will implement the VGG 11. Okay. So what we will do, you will simply implement the for loop. As all of you know, with over this particular convolutional architecture. So defining VGG, what the convolutional architecture, net equals to nn.sequential. So all of us, we know that in case of the VGG 11, there will be 8 convolutional layers. Okay. So what you will do, the convolutional part, the for loop will learn number of the convolution, number of the channel in convark. So net.add clip on, it will add up the VGG block, okay, with number of the convolution layer, number of the channel. Then what will happen once the convolutional part is completed in the code, we'll start with the fully connected part. So in the fully connected net.add in dense, okay, 4096 is the number of the channels, activation function is relu. We will put the dropout layer 0.5 because we know the dropout layer reduces the complexity from the network architecture and it removes the effect of the overfitting. So drop as the value you will get, it basically gives the value for the probability. Okay, so the 50% it will drop out. It will drop from the network layer architecture because the value of the dropout is 0.5. In a similar fashion, nn.dense, okay, 4096 number of channels, activation relu, nn.dropout 0.5, okay, comma, nn.dense, you see 10 because you will get the 10 outputs, return net, and then net equals to VGG arc, okay, convar, VGG convert. So this is a general structure which we have implemented for the VGG 11. Now let me implement the same thing under this VGG demo notebook. You see, I am clicking on the run cell button. So this portion will run successfully. You see the green, every time the code runs successfully, green tick button is coming up. So let me share it with all of you in case of the comment box section. You see already the coding portion has been shared in the comment box. So let me go back to the original notebook. So once we are being able to complete it. So let me go back there to the original notebook section. So now here we have seen that we have constructed a single channel examples with height and width of the 224 to observe the output shape of each layer. So you see net.initialize, okay, nn.uniform distribution we are forming with 224 by 224 height and width, and we are running it under the block for loop. So for blk in net, okay, x equals to block of x. So print blk.name, that means block name, output shape, under where you see the tab sign has been given there, comma x.shape. So it will do the same thing like we have seen in case of our AlexNet architecture as well. So first of all, it will print the block name. Each block name will be there. Then it will print output shape. Tab sign is given there, so some space will be there. Then the shape, number of the layer, number of the channel, then their dimension. So accordingly, you see sequential 1, sequential 2, 3, 4, 5, all the details, it has been printed, followed by dense 0. Because you see Python is a zero indexing language, so it will always start with 0. R is the one in the indexing language, but Python is a zero indexing language. So it will start from dense out, dropout 0, dense 0 in this way. Okay, and it will get the following output, okay, number of the layers and corresponding channel output. So this is the thing you can implement easily in your case as well. Let me show you in my VGG demo notebook as well. This portion is running successfully. So you see, again, the green tick has been appeared. So this portion of the code runs successfully. Also, let me share the same thing in your comment box section, such that all of you will be able to incorporate it quite smoothly. Let me go back to my notebook. So we have been able to done this portion successfully as well. Now let us move to the next portion. Okay, we will do the training. So in the training case, you see this particular VGG Net 11 is more computationally heavy than in case of the AlexNet, all of us know. So we'll construct a network with a smaller number of the channel because this is more than sufficient for training on the fashion MNIST. So we are doing the necessary steps there by defining the ratio equals to 4. So you see this portion of the code I am running here in my notebook as well. Okay, so you can see all these are the runnable chunk of code. So you can see it is also running successfully. It will also, all of you will be able to run in your case as well. Also, let me send you in your comment box section. Okay, so in this way, you will be able to reproduce the results quite smoothly. Now, what we'll do, we will put define all those things like learning rate, number of epochs, batch size. Okay, all those things we will define. And once the execution has been done, you see you will be able to see that training accuracy 93.5%, testing accuracy 92.7%. So it is quite better than the case we have seen in case of the AlexNet. In case of the AlexNet, it was 87 point something. Okay, for the training data set, and for the test data set, it was 88 point something. And you see using the VGG net, the accuracy has increased significantly. You can see the number of the training accuracy has increased. Okay, 93.5, and the test accuracy 92.7. Because you see, the number of the convolutional layer we have increased. AlexNet was having 5 convolutional layers. In the VGNet, we have the 8 convolutional layers. So in this way, we have been able to generate the following plot, where you can see as the number of the epochs increased, you see that the validation loss is decreasing, and you see we have been able to achieve the great training and testing accuracy. But the blue line is giving you the validation loss, where you can see this pink dotted line, and the green dotted line is giving you the idea of the training accuracy and the test accuracy respectively. So the generation will take some time, this kind of plot. So just for guiding you, let me paste this particular portion of the code in your comment box section, as well as in case of my VGG demo notebook as well. So you see, it will take some time, so it will keep on executing this portion of the code. Okay, and meanwhile let me share it in your comment box. So all of you will be able to generate this kind of the plot, but it will take 3-4 hours of time in the execution. So anyway, meanwhile, let me go back to the notebook. So that is how we have seen the successful implementation of the VGG net. Okay, so what the thing we can conclude here, that VGG 11 has been successfully constructed a network, okay, using reusable convolutional blocks. So it has given a general architecture for anyone, those who are the deep learning practitioners, they can develop their own network by using this general kind of block structure. Okay, so different VGG models can be defined by differences in the number of the convolutional layers and output channel. Okay, for example, if you are using 11 convolutional and 3 fully connected layers, what will happen? From VGG 11, it will become VGG 14. So in this way, you can generate different kind of VGG network by yourself while dealing with several data. Okay, so the use of the blocks leads to very compact representation of the network definitions. It allows the efficient design of complex networks. And in their VGG paper, Simonian and Gisserman experimented with various architectures. And in particular, they found that there are several layers of the deep and narrow convolutions 3x3 for more efficient than fewer layers of the wider convolutions. So that was the overall conclusions. Nowadays, we have the other frameworks like ResNet, inception layer, exception layer, but we are stopping here because of the time constraints. If I get the opportunity, we'll discuss in the next sessions, upcoming sessions, with more number of the modern deep learning architectures, and we can experiment with several other kind of the data. Today we have seen it for the fashion MNHT dataset. We can do it for the other kind of dataset in upcoming days. So I will share the notebooks with our respected organizers, and definitely all of you have taken note of my GitHub account as well. So let me share my email ID with all of you. If you face any difficulty or if you have any query, you can contact me anytime. So let me just share my email ID in the comment box section. So this is my email ID. Okay, I think it is visible to all of you. And I also share my hands-on session in my own channel, in YouTube channel, so you can subscribe them as well. It may also guide you, give you the proper guidances, okay, with relevant theory and coding portions. So you can find out my YouTube channel there. You can subscribe me there. All the necessary talks related to the state of art technologies in machine learning, deep learning, AI, as well as blockchain, all those things are there. So also let me share my link of Medium account. Recently, as per the student demand, I have started to write the career guidances for the students in the Medium account. So you can also follow me there as well. I believe it will be helpful for you. And those who have joined later on, for them, I am resharing my GitHub account link. So make sure that you are following me there. All the necessary codes and everything you will get from there. So you will get a lot of guidances as per the requirements. So this one also I have implemented as per the students' requests, and they told me that they are getting hugely benefited from there. So you can also share your feedback over email. I have shared my email ID there. So thank you very much to all the respected organizers for inviting me here. It's a great pleasure to be here in Bengal Institute of Technology, and thanks for the students, their smoother cooperations. Without your cooperations, the event would not have been successful. So thanks to all of you. Thank you very much. That's all from my side.
So Thank you, Mr. SABYASACHI Mukhopadhyay. We are really enlightened from your words. So now it's time for the question answer session. So if the students are interested for asking any question, they can ask to sir.
Hello,
Yeah,
sir.
I have a question
one
actually.
question.
Before the student ask you, one question is actually was coming in my mind, that regarding we are saying that we are actually discussing over here on deep learning, but other than this we have another keyword, that is machine learning. So what is the very basic difference between a machine learning and deep learning?
Definitely,
and
like
how we can understand which type of, whether I should go for a machine learning approach or for a deep learning approach based on the problem.
absolutely. Like during the initial discussions on my talk, I have already mentioned that you see that machine learning, all the techniques having the huge potential. Deep learning is nothing but a advanced machine learning. So in machine learning, what does we do? We use activation functions like sigmoid function, tan hyperbolic function. Now you see these functions are not performance or scalable when we have the data in order of 10 to the power 5, because earlier days what happens that when we used to deal with the data in 70s, 80s, even the 19th era, we have the limited amount of the data sets. For example, it can be 1,000 samples, 500, 100. In those cases, we have seen how those support vector machines, random forest can do many magical stuffs. Okay, so they have provided us extremely well accuracy. But what happened that because of the arrival of the social media and all those things, we have seen there is exponential growth in our databases. We are now continuously dealing with the semi-structured data, for example, images, videos, everything, because we are continuously generating data. And due to that, we require some of the techniques which can be able to process those high volume of the data. Because as I have mentioned, that sigmoid or the tan hyperbolic activation function is unable to process the data whenever we have in order of 10 to the power 5 or nearby 10 to the power 5. So due to that kind of the deep learning architectures has that kind of the potential because of using of the activation functions like ReLU. And as I told you that it was initial attempt to use ReLU, but although ReLU has been having the problem related to vanishing gradient, so that's the reason we often go with leaky ReLU or parametric ReLU. This is one of the advantages. And parallelly, earlier, like I highlighted, that if you see during the 1980s and or the 1990s era, we have problems like we don't have the support related to NVIDIA in those era. But nowadays, you see, it is not only about the software development, but hardware development is also important. So we have the support of the NVIDIA. TPU is also there. I mean, NVIDIA in terms of GPU, and Google came up with TPU. You can see even in Colab, we are using virtual GPU, virtual TPU supports. So we have humongous amount of the support data storage capacity, because you see, thanks to Web 2.0, we have gradually started exploring in the cloud-based performances. So nowadays we can use the cloud-based analytical support. Along with that, we all know that to reduce the latency from the cloud, we can go with the edge computing or the fog computing approaches are also there. So nowadays, from 2000 onwards, we have a lot of supports which was not available earlier. And available, if you see in the 80s, 90s cases, we don't have to deal with that much volume of the data as well. That's the reason you see machine learning has done extremely well. Even now, today's scenario, if you have the data set having the 500,000, it is fine to go with machine learning. But once gradually you are going gradually towards the data in order of 10 to the power 5 or nearby 10 to the power 5, in some cases we take the help of the transfer learning as well in order to facilitate the deep learning architectures, then we can do that. But below that, machine learning algorithms are sufficient enough to tackle those scenarios.
Okay, so there's a question in the chat box, I think. It is, sir, can any way
just a second
be used in the field of biotechnology?
Sure. In biology domain, it has been used in a huge manner. Okay. Whether it is whether providing applications for the early diagnosis of cancer to gene sequencing, everywhere this deep learning has a significant application, from biomedical domain, biotechnology domain, biophotonics domain to agricultural domain, banking sector, everywhere deep learning is omnipresent. Okay, because you see, one important thing just all of us require to understand, that we are not storing data with pen and paper. We are storing data with digital means, using the digital means and medium. So due to that, once continuously you are storing data with the digital platform, you require some techniques to analyze them. If you have the lesser amount of the data set, you will go with machine learning. When you have the data in order of 10 to the power 5 or nearby that, you will go with deep learning, as simple as that. Okay, because you are storing data digitally. So once you are storing data digitally, you should require some sort of the techniques to analyze them, to interpret them. That's the thing we are doing here. Whether it is, sometimes we are doing with the help of machine learning, sometimes we do with the help of deep learning. That's the difference. Okay, so one questions I can see that somebody has asked. Okay, so in AlexNet case, definitely we have used ReLU as an activation function. If you look at the code portion, we have defined activation equals to ReLU. In case of VGG Net, we have used the ReLU as an activation function. LeNet, the architecture I mentioned, which was developed in 1988, which was the first deep learning architecture, but it did not do well because of one of the reason is that they have used a sigmoid as their activation function. And you see, they use the weight decay and other things, and they don't have the supports related to the NVIDIA, because in those era NVIDIA was not there. So that's the reason that architecture did not create much impact on the normal researchers or the and other community. But gradually, you see, because from the 2012 era, we started to get the benefit from deep learning because of the NVIDIA activation functions like ReLU, and we have the huge data storage capacity in nowadays because of the thanks to the cloud storage, cloud facilities, and all those things. Okay, so what is activation function? You see, the activation function at the end of the day, you see, it helps you to make the decision making process. Okay. So if you use, for example, a sigmoid function or the tan hyperbolic function, you will get the probable outcome. Okay, so what happens that it gives you the idea of the scalability apart from the decision making. So if you see, for example, the curve of the sigmoid function or the tan hyperbolic function, you can search in Google and you can check out that it is not the performance or scalable curve. Okay, so if you see the ramp-like curve, in case of the ReLU, it has a ramp-like function curve. If we have the idea of the ramp function curve, we will be able to see that it is continuous scalable curve. Okay, so it is existing for x greater than to 0. Whenever you are defining it for the, it is existing for x greater than 0, and that's the reason you see the continuous scalability in the performances you are getting, because activation function gives you, whenever you are making the predictions, it gives you the scalability factor. Because you see, you will keep on enhancing the training data sets, you will keep on enhancing the convolutional layer. What will happen? Your performance curve will keep on increasing. But if we are not using someone like the top level scalability functions, like the ReLU or something like that, you will not be able to get the accuracy nearby 100%. Sometimes we have seen the accuracy level is saturating 90, 92, 93% with the machine learning approach. But in case of deep learning approach, you can get the accuracy even nearby 100% as well. Nowadays, for example, if now the problem with the ReLU is that at x equals to 0, it has the vanishing gradient problem. If you do the derivative of the ramp-like function, in generally, what does we get? We get a step function if we do the derivative of the ramp-like function. So if we do the derivative of the ReLU, what will happen? You will get the unit step kind of function. Okay, so this kind of questions you often even come across during the GATE exam of PC students, those who are appearing. So in generally, what happens that, so once you do the integration over the unit step function, then you will get you can get back towards your ramp-like function, like ReLU. Okay, so but the problem is that x equals to 0, it is not defined. So the vanishing gradient problem occurs. So that's the reason what we do. We go with the leaky ReLU or the parametric ReLU, because leaky ReLU has a very little value at x equals to 0 or less than to 0 cases, 0.01 value. And due to that reason, we can avoid this kind of the vanishing gradient problem. Okay, so there are many theoretical stuffs are there. So within today's class, it is not possible to cover everything, but anyway, in today's session, I believe that all of you get some idea about in which cases you should use deep learning, how the deep learning era has started from 2012 onwards. We have the prominent and elegant frameworks like VGG Net or AlexNet. We got the concepts quite clear about the activation functions and other stuffs. So these are the one of the major portion we have covered today. But you see, learning has never ending kind of thing. So as we can clarify much more things in upcoming sessions if I get the opportunity again. Thank you very much.
Okay, so from the whole BIT family, we want to.
Sir, I have one question.
Yeah, sure.
If we increase the epoch, in that case, the accuracy always be increased.
Yes, definitely. If you use the ReLU-like activation function, it will keep on increasing, because that's the reason I was mentioning the performance or scalability. But it will take a lot of time. Here because you see we have used epoch 10. Even you can see 3-4 hours it is taking the time to give you the entire graph. So it will take much more time if you keep the epoch much more. For example, you can keep 50, 100, you may keep it, but it will take a lot of time to generate the plot. That's it.
It's always increasing at the time of saturated.
No, you see that if you are using sigmoid or the tan hyperbolic, it will saturate somewhere. But in deep learning, it is scalable around nearby 100%. Scalability is always there. So the loss will keep on decreasing and your accuracy curve will keep on increasing. It is completely relating with the kind of activation function you're using.
Any more question have from the students type? Okay.
Well, so you see the filter size related question you have asked, like I have mentioned during the session, that it was deep, because you see that at the end of the day, we want to match it with the given architecture. Okay, so you can use your own style, but the way is that the way we want to achieve or to match the overall architecture style, the way we started with 28, 56, okay, 112, 224. So in this way, we'll be able to upsample it and exactly match with the architecture size. So that's the reason we have kept on making it double, such that we can make it available for matching with the exact architectural design which has been defined by the original paper. So that's the process we have followed there. Okay.
Okay, so from the whole BIT family, we want to express our sincere thanks to Mr. SABYASACHI Mukherjee for his lecture. Anyway, and so now I would like to call Mr. Tanmoy Pal sir for the token of appreciation. Tanmoy, please,
yes.
It's over to you.
Yes. Thank you, Abhishek sir. Once again, on behalf of IIC BIT and on behalf of me, I thank you, sir, from the bottom of my heart for taking time from your busy schedule to be our guest speaker at our webinar. Your presence and wise words helped magnify our cause in the best possible way, I think. All thanks to your enlightened words, I hope that inspired our participants as well. And we look forward to hear from you, sir, once again. And here, a small token of appreciation from IIC BIT. Is it visible?
Yeah, thank you very much for this wonderfully designed certificate. Thank you very much.
Thank you, sir. Thank you.
Thanks a lot. Thank you so much. Thank you.
Hello, over to you, Abhishek, sir.
Okay, so now I would like to call Mrs. Ajanta Palis madam for the vote of thanks.
Thank you.
On behalf of the whole BIT family. Ma'am, it's over to you.
Thank you, Abhishek Bokshi, sir. Respected teachers and my dear students, I am Ajanta Palit, EC Department Assistant Professor in Bengal Institute of Technology. Good evening to all. It is really a pleasure and privilege for me to give the vote of thanks to our eminent speaker, Mr. SABYASACHI Mukhopadhyay. The session was really very nice, very informative, and very relevant. I want to give vote of thanks to our principal sir of Bengal Institute of Technology, Professor Dr. N.C. Ghosh. I want to give vote of thanks to our president of IIC BIT, Professor Dr. Orpita Chakraborty, Vice President of IIC BIT, Professor Dr. Tapun Kumar Pal, Convener of IIC BIT, Professor Tanmoy Pal, our SDA Coordinator of BIT, Professor Shobhan Nondi. I want to give special thanks to our all team members of SD, IIC BIT, that is Professor Tripti Mojumdar, Professor Abhishek Bokshi, Professor Antara Mukherjee, Dr. Shubrata Chakraborty, Dr. Saurabh Kanti Sarkar, and Professor Doipan Chakraborty for their cordial support and immense cooperation. I want to give special thanks to our very own Professor Debashish Pradhan sir for his cordial support. I want to give vote of thanks to our student coordinators, Deepita Pradhan, Almaz Akhtar, and Piyush Ghosh and others. I want to give my heartfelt thanks to our Techno India group management for their immense support. Thank you all. Over to you, sir.
Thank you, Mr. Mukhopadhyay, and it's a very nice feeling, and it's a very interactive session as well. and hope we will meet very soon for the another session with you. So thank you all the participants, and thank you Ajanta madam for the valuable vote of thanks. So we will conclude the session, and now it's a time to fill up the feedback form. So I request our dear students to please fill up the feedback form so that we can get the data from your side, and we will dispatch the e-certificate, and as well as we will evaluate the question paper that are mentioned over the feedback form. So thank you everyone. We just close the session now. Thank you.